This is for Accelerated Algebra 2. We have September 28th lesson, which is 1.5c, adding and subtracting radicals. So what you guys should have in front of you, and pause the video if you don't have it, there'll be in the corner, but a 1.5c classwork that looks just like this. So you can take notes, the slides match what that has. So when we think about adding and subtracting radicals, we've kind of done it a little bit already, just maybe not to this depth. But if you want something in simplest form, here are your notes, right? No radicand, so no numbers underneath the radical sign that have a power greater than the index, right? We did that last class, right? However many times the index goes into the exponent, you take that many out, and whatever remainder you keep under the radical. You also don't want to have any fractions under the radical, and you also don't want to have any radicals in the denominator, right? Stuff that we already know, but we just want to make sure that we do it that way when we go through these notes too. So, typical example, which you'll see here, right? We have 32x squared over root 3 plus 18x squared over root 3, right? What's wrong with this, even to start, is you have 3's in the denominator. And also, you can simplify 32, you can simplify 18, you can simplify the x squareds. So you're going to break this up into each one. You're going to treat each problem separately. So you're going to do this one, and then you're going to do this one, and then you're going to see if you can combine them, right? And again, you can only combine them if they're like terms. So they have to have the same radical, same index, same x's, everything. So we're going to break this up into the root 32 and root x squared, and then over root 3. And that's just this one over here. Right, so root 32, you can probably see you can take out a 16, right? So the square root of 16 is 4. And that leaves you with the square root of 2. And x, the square root of x squared is just x. So all I'm going to do is I'm just going to move, oh, never mind, I can't. I'll do it in a separate step. I was just going to move the x in front, but we'll do it later. And then over the square root of 3. So we need to multiply by root 3 over root 3 to get it simplified. And we should end up with something like 4x root 6 over 3. And you can't do anything else with that, right? Now over here we have, do it on this side, right? We're going to have the square root of 18, the square root of x squared again, and then over root 3. So the square root of 18 is going to be the square root of 9, which is 3 root 2. And then again that x, because the index is 2, 2 goes into 2 once, so you take out x, there's no remainder. And then over root 3. And we're going to just multiply by root 3 over root 3 again. And we'll end up with something like 3 root 6. So I'm just going to do it over here, plus 3 root 6 over 3, right? Now here you could probably, 3x root 6, forgot the x. 3x root 6 over 3. Now immediately you might say, okay, well I can, since they're all being multiplied, I can cancel these out and just make it x root 6, which you can, but if you're going to add two terms, you're going to need a common denominator, so you'd end up just creating it back over here. So just look at these now and say, okay, they have common denominators, they're both x root 6, both x root 6, you can add those together. So when you add them together, you're going to get 4 plus 3, which is just 7. And again, you don't make it, 2x or x squared or anything like that. You don't make this root 12. You don't make this 6, right? Everything that goes along with the two terms after the 3 and after the 4 stays. So x root 6 over 3. So the final answer is 7x root 6 over 3. So here I want you guys to try this one on your own, and then, so pause the video, and then you can check it. I'll go through the answer after. All right, so this one, we have the square root of 81. I'm just going to break it up, each one like that. So square root of 81 is 9. And then 2, an index of 2 goes into 3 once. So I can pull out 1x, and it leaves me with 1x underneath still. This one, the square root of 27, is the same thing as 3 root 3. But if I did the square root of x to the 4th, if I just broke it up, 2 goes into 4 twice, so I can pull out an x squared. So you'll see here you have two totally unlike terms. So your final answer is just going to be 9x root x and then plus 3, but put the x squared out in front like we did last class. So 3x squared root 3. Right? Not like terms. Don't think you combine them. You definitely can. This next one, same thing. Why don't you guys try it on your own? Pause the video and then we'll go over it. All right, so if we did, I'm just going to do it in here, third root of each of these. I'm just going to break it up. Third root of each of these. So if I did the third root of 128, that's the same thing as 64 times 2. So I can break it up into the third root of 64, which is just 4. Right? The third root of 64. And that would leave me with the third root of 2. Right? Third root of 64, which is 4, times the third root of 2 would get me to that. The third root of x to the fifth, 3 goes into 5 once. And then it has a remainder of 2. So this left side, I'm just going to rewrite it so it looks a little cleaner. I got 4x third root. I really don't know why I did this 2 right here. Hopefully you caught that when I did it. It has a remainder of 2, so it's x squared. It's not 2. You know, the remainder is kind of like the exponent here. So here we're going to have 4x third root of 2x squared. All underneath. Here, we're gonna have to subtract this. So 4, don't forget that 4, right? We're just gonna bring it down. The third root of 18, okay, we can break that up into the third root of 8, which is 2, and the third root of 2. 8 times 2 is 16. Third root x to the fifth, we get that same thing. We can pull out 1x, and it would leave me with a remainder of 2. So that means x times x, right, x squared. So if we look at these, this is going to be 8x. 4 times 2 is 8, this x over here. And then we have third root 2x squared. So these are like terms, right? We have x third root 2x squared, x third root 2x squared, x third root 2x squared. So we can combine these. It's really just 4 minus 8. You get negative 4, negative 4x third root 2x squared. Just like that. So hopefully you got that. And then basically that's it for the actual numbers. We'll do like 1 or 2, actually just do one word problem, and then you have a decent amount of classwork problems. So we'll finish the slides quick. Right, so the area of an equilateral triangle is given by this equation. So I want to find the length of a side if the area is root 27. So since the area is root 27, that's obviously where you'd plug it in. So root 27, I'm just going to simplify it first. It's 3 root 3. Right? Always simplify if you can. And then we have root 3 over 4 s squared. So obviously, we're trying to get s by itself. We need to find the length of side s. So non-calculator problem. What you could do is multiply both sides by 4 over root 3. And you don't feel like you need to simplify this, you know, if you're just multiplying. It's not like it's a final answer. And it's much easier if you don't try and simplify it right away. Because what you're going to have is you're going to have 4 times root 3. I mean, you're going to have 4 times 3 times root 3 over root 3. So this is going to cancel with this. You're just going to end up with 12 over here. And on this side, right, and why do we do that? We cancel those out. We get 12 is equal to s squared. Take the square root. And again, anytime you create a square root, right, which you are doing here, right, you're taking the square root, you need to account for both plus and minus. So you get s equals plus and minus 2 root 3. However, you only have one answer. I just want you to get in the habit of creating plus and minus anytime you're taking a square root. You only have positive 2 root 3, and then units is your label. Right, why? Well, because you can't have a side length that's a negative, you know, distance or something like that. It doesn't make any sense. So only 2 root 3 units. That's your final answer. Okay? So this is what you guys are doing for the rest of class. You have a bunch of practice problems on your classwork, which you probably see here. So we got through that one. So the whole back page I just want you to do in partners. So once you finish the video, you can get with your, I don't know, let's see what we got here. Unit 1. Oh. Why don't you get with your, I don't know what we haven't done. Get with your whole numbers partner, even though it's not really what we're doing. And hopefully I'll finish around the same time so it works out. So get with your whole numbers partner, finish the classwork, and then your homework is all of these problems. So if you do finish the classwork, then by all means, you can do that. Actually, so you actually have a lot of time. Hold on, I'm going to readjust it because I have it in my notes differently. Finish these partner practice problems, right? That should take you a decent amount of time. But then before you start the homework, finish the 1.5b, which was from last class, right? You did the odds yesterday, now do the evens from 1.5b. A little more practice, not going to hurt you. And then if you do finish that, you can start that 1.5c radicals homework, which is on Schoology. All right, so you got 3 things: the partner practice on the back of your classwork, 1.5b evens, and then homework is the 1.5c radical worksheet on the portal.